Hello and welcome to my tutorial. My name is Hansen Hackman. In this tutorial, I'm going to demo how to do image processing using Apache Spark clusters on Google Dataproc. I aim in this project or in this demo to give you a brief introduction about Google Cloud Dataproc and as well as this project, and also to give a brief explanation about the Apache Spark framework, and then I'll go into a step-by-step development of this project, and finally we'll get to verify the result of the image processing um, project that we do together here. I'm very excited about it, and let's get started. So in the past few years, there have been a lot of talk about big data and how it is really transforming a lot of businesses. And big data basically is essentially huge amount of data that is very large in volume and has a lot of variety. It can be structured or unstructured, and basically have not been able to be processed in previous traditional computing systems. But in recent times, many frameworks are coming up, and that has been helping businesses to work on big data and to derive more insight from their big data. And the traditional computing systems basically are not designed to be parallel in nature, but the big data frameworks um, basically harness the power of parallel computing to process these huge sums or huge amount of data and data that might not even have any structure or any schema, such as unstructured, which are called unstructured data, and it's able to really do all this in a very quick time. A typical example is um, Yahoo using Hadoop to really process huge sums of their huge amount of their log files. I think about 3 years of log files, and previously they used to do about 26 days in order to really process that, but using Apache Hadoop, they were able to reduce that to about 20 minutes. So that is a very huge gain in processing time. And image processing itself is also a very computing intensive task to do, and so definitely not suited for the traditional computing systems that are made up of, let's say, a dedicated CPU and storage and some memory. But distributed computing frameworks such as the Apache Spark and Hadoop are basically designed to be able to process huge amount of data usually in the size of petabyte, and image kind of data and videos is able to really process them in a very quick time. So in this project, my goal is to actually give you that feel of it and to do image processing using Apache Spark. Now let's talk a little bit about Google Cloud Dataproc. So here I am in the Google Cloud Platform, and Google Cloud Platform basically has so many features that makes the cloud computing experience very easy to do and also in a cost-effective way. We have so many different kinds of features, networking features, storage features, compute features, and we also have the big data features or the big data suite. And one of the big data suite is the Dataproc. Dataproc essentially helps you to create clusters of computers and basically to execute um, huge huge tasks and huge amount of data using these clusters. It allows you to use programming tools such as the Apache Spark and the Hadoop and the Hive and all those other programming available for big data. So that is essentially what Dataproc is. It is a managed service that basically means that Google takes care of all the backend processes, you know, takes care of managing and administrating those computers and making sure everything is working well. The end users only get to use the features that Dataproc provides. Now let's talk about Apache Spark. Now, Apache Spark is an open source project, basically, and it is designed to help do distributed computing and processing of very large volumes of data. But it is an in-memory kind of technology. It's kind of loads all the data into RAM and does the processing in RAM, and but it also can has the capability to use the file system like Hadoop does. So in Apache Spark, the basic feature or the basic data structure is called the Resilient Distributed Data Set, or the RDD. And the RDD essentially is a kind of a distributed storage format where the data is partitioned into smaller blocks and then distributed across the clusters within across the computers within the cluster. So and it's very efficient and resilient because it's able to, for example, if there's a loss of one data block, it's able to reconstruct that data block and reuse it. So it's very resilient to failures and fault, and it's very efficient when you want to um, really do quick processing of data on huge volumes of data, on huge data set volumes. And so that is the RDD. But in it call, the Apache framework is made up of two essential processes. One is the driver process, and the other is called the executor processes. The driver process resides on the master machine, and it's the driver processes is what actually creates the RDD. It's a Java process that is designed to help you create the RDD, split the data into different blocks and spread them across the clusters. And whereas the executor process is essentially designed to execute the task. Or for example, in our case, we are going to do image processing. So um, the the executor process is what is going to handle that piece of it, execute all the tasks across the the clusters in parallel, and then finally give you an output. Essentially, the driver process coordinate or is a central coordinator and coordinate all the executors within the Apache cluster. Now let's get into the project itself, and let's begin doing some real work on the Google Cloud Platform. So this is the Google Cloud Platform, and essentially I'm going to begin by creating a new project. So on here you click on the project window on top here, and then you create a new project. So create project. I'm going to call this project image um, image processor project. And then I hit create. It takes some time to create a project. Now my project is created, as you can see here, but there are no resources assigned to it yet. So in this project, I'm going to use a compute engine, and that's going to run a virtual machine. So I go to the compute engine and I go to virtual machine instances, and I'm going to create a virtual machine instance. Take some time to get it ready. Now let's go ahead and create the VM instance. So let's give it a name, and I'm going to call this VM image process. And then I'm going to keep the region as it is in US Central Iowa. And then I'm going to go to the machine type, and here I'm going to choose, you can choose any machine type that you want, but for this project here, I'm going to choose um, the N1 standard 2 virtual CPU that offers 7 gigabits of RAM, 10.5 gigabits of memory or RAM. So that is the computing um, environment that I'm going to choose. It's going to give me 2 virtual CPUs, and then it's also going to give me persistent disks. I have a persistent disk of about 10 gigabit, 10 gigabit. That is okay for this project, but you have option to change it. But I don't want to do that, so I just want to cancel it. And I'm going to say allow full access to all cloud APIs, and use the service account as it is. All right, so I go ahead and create this. It takes some time to create it. Give it some time. Perfect. So now our virtual machine instance is created, and now we can go ahead and use it. So what I'm going to do is I'm going to SSH into this, and Google Cloud Platform makes it easy by just clicking SSH here. It's going to open up an SSH terminal for you, and you can use that. Or you can actually use the IP address and use PuTTY to SSH into it. But for this project, for this presentation, I'm going to use what Google provides. It takes some time to spin up. Okay, there we are. We are ready to roll with it. So this is the project that I'm in here, the image processor project. So for this, what I want to do first of all is to connect this project here to my GitHub. I have a GitHub project folder for this. So I'm going to first of all try and generate some SSH keys. Let's see, RSA. And then let me save it here in the same file here, and I will give it a password. Re-enter. Perfect. So now I have my SSH fingerprint created, and now I can actually get this SSH key and cut into it or open it and read it, and then use it to link my GitHub repository. So when I cut this, then I can copy this and then add the SSH key to my GitHub repository. It's currently an empty repository, but I'm gonna add things to it as we go on. So you go to settings, SSH keys, new SSH key, and you can give it a name. Image processing project, and then add it here. So now I have it. I have that SSH key to this project linked to my GitHub, and I can go to my project here and then clone into the the link that GitHub provides to clone into the project here. So I copy the SSH um, URL, and here I can do git clone this. Oh, unfortunately I don't have git here, so I can do apt get apt-get install git. Oh, I need to do a sudo apt because I don't have the root, the privileges here to do that. Okay. It takes some time. All right, there we go. So let's see if git is installed. I say which git. All right, now we have git. So now I can do git clone and the part again. Say, are you sure you want to? And I say yes. Yes. All right. I have to enter my passphrase, and there you go. So I basically have the project here. If I do ls here in my home directory, you see that the project is being brought into from GitHub. So that is the project name that I call this project here, Dataproc image processor, and it's currently within my Git repository. And a minute, let me navigate back to my SSH. Perfect. So I'm going to do everything in this project within the Git repository. So I'm going to cd into that. There you go. There you go. So that is my Git. It's basically it currently has only the README file. So what I'm going to do next is to begin installing some libraries that I'm going to use for this image processing and use for basically connecting my clusters and reading data from my clusters. And these libraries are called the Scalar and the SBT libraries. So I'm going to install, do some bit of installation to get these libraries installed. So I first of all need to see if I have directory manager installed. So I have to do get install -y. All right, it's installing it. Perfect. Let me try and update the packages. You see, so the apt-get update. I assume that whoever is going to view this have some basic knowledge of Linux shell scripts or Linux commands. So that is why I'm not really explaining all these things. Now that is done, so let's go ahead and install some more packages that I will need, because I'll need to do some HTTP commands here. So I need to also install transport HTTP. So let's do sudo apt-get install -y and apt transport .https. That is also done installing. Awesome. Now let me try and do another command here. I need to do all this installation to enable me to get me ready to install packages scalar and SBT. I'll talk about scalar and SBT in a short while. Pipe it here. Okay, looks like I had an error in this here. So what I'll do is this. I have the command already. I've typed this command already here, and I'll use that command as I have it in my project that I already worked on here. So that is done. And then we need to connect to the key server. So all this is just the prep, to help us use Scalar and the package SBT. So I'm basically prepping the environment. Let me try and update the sudo get update packages again. Oh, that's wrong spelling here. What did I do wrong? Let me see. Sudo apt-get update. They're just not known. Sudo update and blah blah. That should work. All right. The list of sources could not be read. Put it. All right, that's okay. Let me just install the. Let me just install my SBT. Install -y bc scalar SBT. Interesting. I get some errors here. So based on the error that we're getting, it looks like the sbt.list file is malformed. So this is what I'm going to do. I'm going to do nano into the file, and I'll basically make it an empty file and try and see if it's going to work. So I'm going to clear its content, move everything from it. Okay, so I've cleared the content of it. I'm going to save the file. Do Control O in Nano, and I'll write it here. Control X. Now let me try and do apt-get install again, and now apt-get install works. So now let me try and install Scalar and SBT again. So sudo apt-get install -y Scalar SBT. Okay, so it's not able to locate SBT. Let me try and install just Scalar and see if I'm gonna get it. Okay, so it's able to install Scalar. take some. Okay, so I had to install SBT, and what I essentially did was to create my connection to the Debian server that hosts Scala and SBT again, and essentially now install SBT. It looks as if the public key that I initially got from the initial running of this command here. Let me just do my back arrow um, of this command here was not really working, so I had to recreate it, and then I had to install SBT again. So now I have a SBT installed, as well as I have Scala also installed. So if I do which SBT, it should give me the location of SBT. And let's do which Scala, give me the location of Scala. So that was an interesting thing that happened. Very interesting. And that is the whole feel about programming. Things sometimes don't work and you have to research and solve the problem. So now, what is this Scala and what is this SBT? So basically, Scala is a way, is an open source project that kind of helps you to create parallel tasks of parallel programming. Is a functional kind of a functional kind of programming language, and it essentially helps you to do parallelism inside your project. And the SBT is another tool inside a Scala project, and it basically helps you to kind of create Java archive files, and that is essentially binding together or bundling together so many files into one file, or into one Java archive file, a jar file, and it's essential in this project because we will have to use this to bundle the feature detection files from its GitHub repository and using it in this project. So now we have the environment ready, Scala and SBT are ready. So as you can see now what I would like to do is to clone the Cloud Dataproc project from Google repository, and I'm going to basically go into that project in Google's. So these are some of Google's open source codes that I'm using here. So I need to get to the the HAR machine learning project, and the HAR machine learning project is also an open source project that helps you to do image detection essentially, or feature detection in video and image streams. So that is the HAAR um, library, and we need to bundle that using um, we need to get to that using Git, and we need to feed our images that we're going to detect to that particular um, machine learning library. So let me try and update my packages again. Sudo apt get update. Now I'm going to clone into Google's um, open source code in GitHub. All right, so I have that, and then let's see if that came through. Yeah, so that came through. We have that cloud data project in my folder now. And now let's see if we could um, navigate a little bit into it. So let me see where the location of the open source for the HAR code is. So Google's Labs, OpenCV, and HAR Cascade. So as I've said earlier on, the HAR project is for image feature detection. It does other things, but one of the things that it does, this open source library does, is to detect features in videos or images. So that is essentially why I'm using it, because in this project the goal is to you know get a group of pictures and use it to detect like faces, right? The faces of people in the picture, and then kind of draw some squares around the faces to say, hey, this is a human face, or this is another human face. So that is the essence of this project. So now with this, with here, while I'm here, I can now use the SBT to build the jar file for the HR library. So I'm going to do SBT assembly. It's basically going to build what we call a fat jar file for the feature detection detector um, program. It's going to take some time. As it say that this may take some time, so let's give some time. Perfect. So it's done building my feature detector files. And as I said earlier on, the SBT essentially packaged together all the feature detector files from the HAR project, and that is what we are going to use for the feature detection. So now we have a single build file that is going to be used for feature detection. So now, essentially at this stage here, we are ready, the environment is ready, but then we so far have not talked about creating the clusters yet. And, um, and for example, loading images into the cluster. So this is what we are going to do next. First of all, I will need to, I'm going to create, um, I'm going to create a bucket, Google Cloud bucket. And there are two ways to do that. You can do that from the command line, or you can actually do it also um, from the console. So if I go to storage, I can do storage here. If I go to storage, I have create bucket here. So I can easily create a bucket from this end here, the name of the bucket, and basically create it and assign it a time zone. Or I can actually create it also from the command line. So let's try the command line and see how it is done using a set of commands. So first of all, to do this, what I'm going to do is I'm going to create some set of variables that I'm going to use. So I'm going to say I'm going to create a variable called image project. That's going to store the name of my project, and it's going to get me. I'm going to use a gcloud command. Gcloud. Let me make this bigger so that we have it all here. Gcloud config, and I get the value of my project, basically the name of the project. This should be this. Now if I do echo image underscore project, it's my bad. Let me do image that, echo that. So yeah, it gives me the name of the project. So the name of the project is image processor project, right? So that's it. And then let's create a name for a bucket. Um, let's create a variable to store that and call it my bucket variable, and say it's equal to Well, let's just call it a name. My bucket, the name of my project is my bucket is going to be called process process image process bucket. IMG process bucket, for example. What did I do wrong here? Um, my bad. I should bring a dollar here. Why is it not working? Let me see. Yeah, so I think the issue had to do with a little bit of space between the space here between bucket and the equal to sign. So now I've assigned a variable that value. Let's see what it stores. Let's see my bucket. All right, let me try this again. I think I did not get it working well. My bucket should be equal to image process bucket. Let's do echo my buckets. Okay, echo. Let's do this. Okay, so yeah, so my bucket is called image process bucket. So I'm going to go ahead and you could actually simply use the names of the bucket and the project or the project that you have directly in the code, but I wanted to create variables to do that. Um, so now let's see. Let's create the let's make a new bucket. So let's do gsutil mb dash the make bucket, and I'll do the name of my bucket. Let me just call it the name that I created here, and that is image um, process bucket. So this is going to create a bucket, and that has been done. So we could actually verify it and see if that is being created here. Um, Let me go to storage. Yeah, so you can see that that bucket has been created in the console over here. But it's currently, when you look at it, it's currently empty. There is nothing in it. So we're going to add some files to it. So I have a set of files that I want to detect images from. So what I can do is to upload the files from here. So there are two ways of adding files. You can actually use the you can actually, let's say, download them from somewhere over the internet, or maybe some a server that you have that stores your files, or you can also directly upload it from your PC. So I'm going to do that here, and I should have my document somewhere here. A minute, I should find it somewhere. Okay, so let me upload those files. I think I have found where they are on my PC, somewhere far away. So these are the two files I want to upload, and I just upload them. And now those files are present in my bucket. Alternatively, I can also download I can also download a file from the web using the curl command. So we can also try that. We can also try using the curl command to download a file from the web. So let's try using the curl command to download an image file from the web. So what I'm going to do is I'm going to do curl, and I have the URL for that image. It's a JPEG image. Then I'm going to pipe it to, that should be a pipe, not to GSUtil, and I copy it to pipe it to GSUtil. Copy is a CP is a command to copy files, and I copy it to the bucket that I just created. Bucket name is image. It should get me, if I do the tab, I believe so, image. All right, process bucket, and the name of the file I'm just going to call it let's call it ut image .jpg, same format. Perfect. So it's I used two techniques here. One, I manually uploaded the files to my bucket, and another technique was that I also curl to download an image to the bucket that I have. So that is pretty interesting. I have those images now, and let's try and see if we could see them here. GS util to list. So GS util is Google Cloud's function or command line function to basically communicate with its cloud resources. GS util ls and read those files. The name of my file is image process bucket, and let's see what we have. So we have those three files, all of them there, and showing up in my folder. So now with our bucket ready and having the files in there, now let's go ahead and create the cluster. And to do that, I first of all need to set up the region where the cluster need to reside. So I can do that on the command line and say gcloud config set to the proc region. So I'm going to set the region for the proc, and I'm going to use a global region. All right, so the region is updated. Now let's go ahead and now create the cluster. And the command to do that is the gcloud, but then we have the Dataproc because that is where the clusters reside. Gcloud Dataproc. And what am I creating? Clusters. And then the name, I use a create command, and I use the name of the cluster I want to create. So I'm going to call my cluster image cluster, and then it's going to reside in which bucket. So I have to supply the where the storage, the bucket is going to be the name of my bucket, and that is GS image process bucket. Then I need to supply the worker node or the worker machine. As I explained earlier on, this is distributed computing. So there's a worker node and the master node, and I said that the master node is actually what we refer to as a driver or it runs the driver process, and the workers are the executors. And for this, I'm going to um, say machine type. The machine type should be coming on the standard. We want standard 2, and the master machine type is also the same. We want to use then one standard 2 has two computers in each. So I think for this project that is enough. Standard 2. So now it's asking me what I want to create a cluster called image. I say yes. So I say yes. He said API not enabled on project. Would you like to enable? I say yes. It's going to take some time. So I think I got an error in the process. I think it's probably how I named my bucket here. I don't think I'm supposed to put the parentheses run it. Let me see if that works. Say yes. Okay, so I have the error again for that. So it looks like it's not really understanding the format of the file. So let me fix that. Okay, so let's try again. Try and fix it. I believe is an issue with this piece here. So let me remove the GS colon um, colon slash slash and run it again and see if it's gonna run. Okay, cool. So it's actually creating the cluster. Perfect. So let's give it some time to create the cluster. Perfect. So we've done creating um, the cluster and created in the US Central's region. So our cluster is ready. Perfect. And let's see if we can actually navigate to the cluster in the console. So let's go to Dataproc. Uh-oh, I went to data prep rather. It should be Dataproc. Okay, let me just get out of there. Dataproc. That's what I want. And see if the cluster is going to show up. Perfect. So we have the cluster created here. As you can see, image cluster created, and currently it's running. As you can see here, the timestamp, the region, and the zone. So we have the cluster here ready. Now let's go ahead and go to our SSH window again. So now one step we need to do before we actually begin predicting, detecting the features is to now load the configuration file for the feature detection into our bucket. It needs to reside in the same bucket where the files are. So that is what I'm going to do right now. So I'm going to do a curl, and I need to get the path of the project, that XML file. And then I pipe it to, pipe is basically a way of, in Linux world, a way of feeding the output of one command into another. So here I'm curling or downloading this file, and then whatever is the output, I'm actually going to copy it into my Google Cloud bucket. So GSG2. And I do copy, and I basically have to take it to where my bucket is, image process bucket, and I just call it the same name as the file, the XML file is from the source. So I have it, it's downloaded. Perfect. So we have it in my bucket now. That is awesome. So now I'm going to now feed the images that I created and going to submit it using Apache Spark to basically run the image processing and use a class that I created to do the feature detection in the images that I feed it. So that is going to be very interesting. So to do that, first of all, let me see if I'm in the OpenCV. In the OpenCV, yeah, that's where I am, PWD. I'm there, where the HAAR or the HAL cascade code is. So what I need to do is to essentially use the jcloud command again. Jcloud, I do Dataproc and jobs. So this is an Apache command, Apache Spark command. Jobs submit a Spark Apache Spark command. Let's go to the next line to make things easy, and then I can feed it with the cluster name, the cluster that I created. And the cluster that I created, if we remember, is image cluster. So I just say the cluster name is image cluster. I want to be sure. Should it be in? I think it should be in quotes. Image cluster. And then let's go to the next line to make things nicer. I feed it with the jar file that we created. So what we did the assembly, if you remember. So jar, the target is going to be that jar file we created. So it's going to use a scalar to do the parallelism, as you remember. As you remember, we talked about, and you're going to use a feature detector piece of it. So I'm basically feeding the jar of the location of the feature detector assembly, and that is what I'm doing here. Feature underscore detector dash assembly. That's the name. The assembly dot 1.0. That's the name of the file. And then I can do dash dash the bucket. Let's come down here to make it easy to see the bucket. So you need to pick the XML file that has the face detector configuration that we just did in the previous step. So I have to go to my bucket. My bucket is image process bucket, and then the name of the file is usually we should do the top. You should give it, but I don't know. Let me try and type it or copy the name of the file as I have it previously somewhere here. So this is the name of the file. So there's a whole bunch of commands that we need to use. So now we fed it with the configuration file. The next thing is to give it the direction, the location where our files is. Now let's be sure, first of all, where I have my files in my bucket here, so that I don't pass it the wrong location basically. So I go to storage and let's see where I have the files. Oh, so they are just in the bucket there. So yeah, let's do some organization here. Let me create a folder, I believe. Is it possible to do it from this end here? All right, let me refresh this and see. So we have two here. There should be three files, I believe. Oh yeah, I've not gone to the bucket. That's very bad. Yeah, I've not gone to the bucket. So yeah, this is the bucket. So this is image process bucket. Perfect. Now let me create a folder and just try and organize things here. So I'm going to call this folder image and create it. And then I'm going to move this pictures here. Can I do it more than one at a time? Let me try and see. Okay, let me try and see this. If that is going to be is possible. I don't think so. I cannot move it. Let me see what I can do. Move. Okay. Browse. Image. Select. Move. All right, so it does one at a time, unfortunately. Um, let's just do that. Browse. Select that image folder. We move them to it. The last one is this. Move it. And say move. So perfect. So now um, in here I have my images all here. That is perfect in one folder. And let me create another folder in here that is going to have the processed image. So create folder, processed, processed out. Let's just say process images. All right, perfect. I'm going to use this folder definitions to locate where my files are. So that's I need to get to the location of my files. So where the input files are. So I go to my bucket. My bucket is the image process bucket. And it is in the image folder. And then we move to where I want to output them. So to GS image process bucket. And I believe we called it process images. Let's just sure. Processed underscore images. Processed underscore images. I believe so. Yep. Just be sure again. The command does not fail. Processed underscore images. Awesome. So now I'm going to run this, and now it's going to begin to do my feature detection. So the job is submitted to the Apache Spark cluster, and is using the feature detection from the HAR library to detect faces in those pictures that I fed it. It's going to take some time. Number of files found is 3. So it's basically running perfectly as we wanted. So let's give it some time and see. Let's see. We can actually view the the jobs that we have here, Dataproc, and go to Dataproc and go to jobs and see if the job is showing up here. All right, so the job is running, and is this done here? Cool. So it's actually done running. The job is done running. Perfect. It's done the feature detection, face detection, process all the images. So what do you see that this took a very short time to do that, very short time. But honestly, to do the same amount of um, image processing in a traditional computer that have let's say just one or maybe two computers, and they are all in one place and really not distributed, and just doing it raw, it's going to really take a very long time to process and to do the feature detection in the images. So now let's go to the job and see it is done perfect over here. And we could actually now go to the storage location and see if the file is there. So you can actually click on this tool to see some of the things that happened. A lot of things went through, everything went on, and it did all this in just 42 seconds. That is super fast, super fast. And when I say all this, basically, breaking these image files into smaller bits, and storing them into the RDD, the resilient data format, and then applying um, Apache executors to work on them to implement the feature detection algorithm that we fed it, and all of that, and give it in just that short amount of time is pretty incredible, I would say. So let's go to storage again, and in the storage, let's go to our bucket, image processor bucket. So let's see the process image. So we have three, right? So three process image, and just giving it the same names. And I can download one of them. Let me just click on one and download it, and let's see whether it's able to process it. So you see, as you can see, it did a pretty good job. It's not perfect, but you can see that it's able to detect faces, right? It detect the face of this lady here, this gentleman here, but sometimes it also failed here. It saw a face at the back of this guy's shirt, and faces here. Here it detected somebody's ear and said that ear is a face. But I think they did a pretty good job detecting faces. Let's look at the other ones too. And so let's look at this one, rush hour. Was it able to detect faces? Well, for this, it did not go. It did not do a good job. I could not see any real detection of faces. Am I in the right folder? Let me just, yeah, process image. So I wasn't able to do any reasonable detection there. Let's go to this one here, use image file, and see if it's able to do some. Yeah, so here it's able to detect few faces. It's detected this lady, and yeah, those are the only two detections. So I mean, this is pretty much what I set out to do to demonstrate how to use Apache Spark clusters and to run a image detection algorithm, or yeah, a machine or image detection machine learning tool like HAR, and use it to detect images, detect faces in an image. And I believe this was helpful, and hit like if you like this video on YouTube. Thank you.